Now let's explore regularization in regression, a technique used to avoid overfitting. Recall that fitting a linear regression model minimizes a loss function to choose a coefficient A for each feature and the intercept B. If we allow this coefficient to be very large, we can get overfitting. Therefore, it is common practice to alter the loss function so that it penalizes large coefficients. This is called regularization. So, ridge regression, the first type of regularized regression that we will look at this called ridge. With ridge, we use the ordinary least squares loss function plus the squared value of each coefficient multiplied by a constant alpha. So, when minimizing the loss function, models are penalized for coefficients with large positive or negative values. When using ridge, we need to choose the alpha value in order to fit and predict. Essentially, we can select the alpha for which our model performs best. Picking alpha for ridge is similar to picking K in kernel. Alpha in ridge is known as a hyperparameter, which is a variable used for selecting a model's parameters. Alpha controls model complexity. When alpha equals 0, we are performing OLS. When large coefficients are not penalized and overfitting may occur. A high alpha means that large coefficients are significantly penalized, which can lead to overfitting. So let's regression, ridge regression in Scikit-Learn. So to perform ridge regression in Scikit-Learn, we import ridge from Scikit-Learn.linear underscore model to highlight the impact of different alpha values. We create an empty list for our squares, then loop through a list of different alpha values. Inside the for loop, we initiate the ridge, setting the alpha keyword argument equal to iterator, also called alpha. We fit on the training data and predict on the test data. We save the model's R-squared value to the scores list. Finally, outside of the loop, we print the scores for the models with 5 different alpha values. We see performance gets worse as alpha increases. Lasso regression. There is another type of regularized regression called lasso, where our loss function is the OLS loss function plus the absolute value of each coefficient multiplied by some constant alpha. So to use lasso, we import it from Scikit-Learn.linear underscore model. The actual method for performing a lasso regression in Scikit-Learn mirrors ridge regression. As we can see here, performance drops uh, substantially as alpha goes over 20%. I mean, yeah. Lasso regression for feature selection. Lasso regression can actually be used to assess feature importance. This is because it tends to shrink the coefficient of less important features to 0. The feature whose coefficients are not shrunk to 0 are selected by the lasso algorithms. Let's check the check this out in practice. So we import the lasso. Next, we create our feature and target arrays and use the datasets dot column attribute to access the feature names and store as the variable names. As we are calculating feature importance, we use the entire dataset rather than splitting it. We then initiate the lasso, setting alpha to 0.1. We feed the model to data and extract the coefficients using the dot coefficient underscore attribute, storing as lasso underscore coefficient. We then plot the coefficient for each feature. We can see that the most important predictor for our target variable blood glucose levels is the binary value for whether an individual has diabetes or not. This is not surprising, but is a great sanity check. This type of feature selection is very important because it allows us to communicate results to non-technical audiences. It is also useful for identify which factors are important predictors for various physical phenomena. Let's practice. So I'm creating one new this is my new Jupyter notebook. Here I'm first importing the diabetes data. So what is the diabetes data? This is I'm importing the import statements, then diabetes data, diabetes is the first five rows, and I'm removing the zero values from the diabetes on glucose levels and BMI, and diabetes is my glucose is my I'm removing the glucose where glucose is my target value, and I'm storing target value y in a glucose as a target y value. I'm splitting the data, test and train, and I'm using the ridge regression where this is the ridge, this is the values. So when the alpha value is increasing, it is the values are worsening. Decreasing. So 35 0.35. The last value is 0.22. When that is when I'm applying the lasso. So lasso when this is also same when the alpha is increasing, uh, going to down. The values are down. Now when I apply this particular this thing, what you call coefficients. This is the coefficients of the the coefficient values. So when I plot the coefficient, so if you see the coefficient, so diabetes is the important variable in the prediction in the data set, diabetes data set. So it is 0 and 1, that is binary values. So this is the important values in this thing, diabetes data, and same thing I'm using the same what you call for the sales data also. I'm writing the sales data also. I'm using the same code, but data frame is data is different. So what I'm doing, I'm importing the again these things, and now I'm using the sales data. So we need to go into use the lasso regression and find the which variable is more important for our prediction. So splitting the data here and applying the ridge regression, ridge. So when this is everything is 0.99, and lasso also I think same. Yeah, lasso also same. And we taking the then we are taking the coefficients. These are the coefficient. We're going to find the which variable is more important. So here TV is the TV column feature is more important because the remaining are I mean it's not giving that much this thing, but this is the very important variable. Yeah, this is lasso and ridge. So please work on it. Thank you.